The Deadliest. Radioactive Places on Earth. Part 2.
Sellafield, Cumbria, the United Kingdom. On the coast of northwest England is Sellafield. It's one of the most significant nuclear sites in Europe, and a place marked by abandonment in parts of its complex. Originally, it was constructed in the 1940s under the name Windscale. It was built to produce plutonium for the United Kingdom's nuclear program. Over time, Sellafield expanded into a big facility that housed reactors, fuel reprocessing plants, and waste storage areas. Its troubled history includes one of Britain's worst nuclear incidents, the Windscale Fire of 1957. A fire broke out in one of the reactors used for production, releasing radioactive iodine into the atmosphere. Milk from surrounding farms was dumped for weeks to reduce exposure to local populations. Though the fire was eventually extinguished, the incident showed the risks of nuclear facilities and left contamination inside the damaged reactor building. This activity generated huge amounts of waste, some of which was discharged into the Irish Sea, raising international concerns about contamination. By the late 20th century, though, many of the original reactors are gone. The entire sections of the site now stand abandoned or sealed off, including the reactors built for early weapons production. Cleanup and decommissioning work here has become one of the largest engineering projects in Europe, projected to take over a century to fully complete. Hazardous areas like old waste silos, storage ponds, and contaminated buildings require constant monitoring and handling. The site, of course, is heavily restricted, and while some workers remain involved in the cleanup, the abandoned facilities are off-limits due to the lingering radiation. Large portions of the site are going to remain unsafe for habitation indefinitely. Though it was never a residential town, the abandoned buildings here earned it a place among the world's most significant radioactive sites, where human presence was permanently receded. Number 14. The Nevada Test Site in the U.S. Just 65 miles northwest of Las Vegas lies the Nevada Test Site, now called the Nevada National Security Site. Established in 1951, it became the main location for nuclear weapons testing in the U.S. during the Cold War. Over 4 decades, the site saw 928 nuclear tests, both atmospheric and underground. The results of all this were dramatic: craters, abandoned bunkers, test structures, and widespread radioactive contamination. The earliest tests were atmospheric, with massive mushroom clouds that were visible from Las Vegas, and tourists even once gathered in the city to watch the detonations, unaware of the health risks they posed. After 1963, though, testing moved underground, following the Limited Test Ban Treaty, but even those detonations created contamination in the soil and groundwater. The Sedan crater, made by a 104-kiloton underground test in 1962, remains one of the largest man-made craters in the world. It's 1,280 feet wide and over 300 feet deep. This detonation was part of Operation Plowshare, a program to explore the use of nuclear explosives for civilian purposes like mining and canal building. While the crater is still visible, the surrounding soil remains radioactive. Much of the Nevada test site is abandoned, with remnants of buildings and observation towers, and some structures were built to test how cities, houses, and vehicles would withstand the nuclear blasts. These mock towns, complete with mannequins and furniture, were vaporized or heavily damaged during tests, and the site remains eerie, like ruins. The abandoned testing ground shows how once a highly active military zone became a place way too dangerous for ordinary use. While not a traditional settlement, the abandonment of its facilities due to radiation ensures its place among the world's most significant radioactive zones. Number 13. Kapustin Yar, Russia. Kapustin Yar is located in the Astrakhan region of southern Russia. It's best known as a secretive Soviet missile testing site, but it does have a history of radioactive contamination and abandonment. Established in 1946, it was used for testing new ballistic missile designs, nuclear weapons, and later space technology. Because of its secrecy and proximity to rural villages, local populations were often directly affected by fallout from tests. Between the late 40s and 60s, the Soviet Union carried out multiple above-ground nuclear weapon tests here. They weren't as numerous as those at Semipalatinsk, but they were significant in scale. The blasts here spread radioactive fallout across the surrounding region. Long-term health studies have shown higher rates of illness, including cancers and genetic disorders, among the populations exposed to fallout from these tests. When the nuclear testing phase ended, many of the facilities were abandoned and structures like underground bunkers and observation posts still stand, but remain unsafe due to the lingering contamination. Over time, Kapustin Yar shifted focus to missile-related tests, becoming an important part of the Soviet and later Russian aerospace program. However, the contamination from earlier testing has never fully been remediated. Local villages affected by fallout during the mid-20th still bear the consequences, and some settlements were relocated or abandoned entirely. Kapustin Yar is a site of technological progress, and it's a radioactive wasteland. The secrecy surrounding it has left much of its contamination undocumented in the public record, and while partially still active, large sections remain deserted, unsafe, and effectively abandoned to time. Number 12. Oak Ridge, Tennessee, the United States. Oak Ridge, Tennessee, often called the Secret City, played a central role in the Manhattan Project during World War II. Built almost overnight in 1942, the city was designed to house tens of thousands of workers and scientists engaged in producing enriched uranium for the first atomic bombs. While Oak Ridge itself is still inhabited today, several of its wartime facilities and surrounding areas have been abandoned and remain contaminated with radioactive material. The most significant facilities here were the Y-12 plant, the K-25 gaseous diffusion plant, and the X-10 graphite reactor. These complexes were used to enrich uranium and produce plutonium. At its height, the population of Oak Ridge exceeded 75,000, with strict military security and secrecy preventing outsiders from knowing what was going on in there. When operations wound down after the war and later during the Cold War, many of the original buildings were decommissioned. The K-25 plant, one of the largest buildings in the world, was closed in 1985. Other facilities like the waste storage ponds and burial grounds for contaminated materials also added to the radioactive footprint. Waste from the early years of nuclear work was often disposed of hastily, leading to leaks in the surrounding rivers and groundwater. Mercury contamination from Y-12 operations has been another long-term issue. The U.S. DOE, the Department of Energy, has since declared several sections of the site unsafe for public use. Now, what makes this place unusual compared to other abandoned radioactive places is that the city itself survived, and it still thrives. While part of its nuclear infrastructure stand abandoned, the surrounding countryside contains disused reactors, waste disposal sites, and restricted areas. Visitors can tour parts of Oak Ridge and have been cleaned and preserved, like the X-10 graphite reactor, now is a National Historic Landmark. The abandoned zones within Oak Ridge are often not as visible as ghost towns or ruined villages, but they show how quickly massive industrial facilities can become unsafe. Oak Ridge's legacy is going to be twofold. It was critical to ending World War II, yet it left behind an environmental burden. The abandoned facilities demonstrate the long-term cost of nuclear development, showing that even with cleanup efforts, radioactive contamination can outlast the original purpose of a site. Number 11. The Chalk River Laboratories, Ontario, Canada. Chalk River Laboratories is located along the Ottawa River in Ontario. It's one of Canada's most important nuclear sites. It was established in the 1940s during World War II as part of a joint Canadian-British effort to develop nuclear science for military and civilian purposes. But it also was infamous for two serious accidents in the 1950s that released radioactive material into the environment. The first major incident happened in December of 1952 when a reactor at Chalk River experienced a partial meltdown. Radioactive gases and water were released into the environment, and the cleanup required dismantling part of the reactor building. The Canadian government downplayed the event at the time, but it's now recognized as one of the earliest nuclear accidents in the world. A second accident struck in 1958 when another reactor at the site suffered a fuel rupture and a fire. This event released additional material, including contaminated water that entered the Ottawa River. For decades after, Chalk River remained active, producing medical isotopes that were shipped around the world for diagnostic and treatment purposes. At one point, it was one of the largest suppliers of isotopes such as molybdenum-99, which is critical for cancer diagnostics. However, many of the earlier reactor buildings and associated buildings were shut down and left abandoned, but the aging structures contained contamination from the past operations and have since been sealed off. Today, the Chalk River site is a mix of active research and restricted zones. Some modern labs continue to operate there under strict safety standards, but older sections are contaminated and unsafe. While it contributed enormously to nuclear science and medicine, its older, abandoned zones serve as reminders of how early nuclear research often left behind unsafe legacies. It's not as visually dramatic as a ghost town, but the sealed reactors and closed buildings represent radioactive abandonment every bit as much as more famous exclusion zones.